Okay, let's get started. So, hello and welcome to this webinar. Thank you all for joining us today. My name is Stuart Scott from Cloud Academy, and over the next hour or so, we should be discussing how to design and build secure serverless applications on AWS. So we'll be covering two hot topics at once, serverless and of course, security, which is a fundamental component of any build on AWS. And with the continuous drive of serverless solutions across the cloud with the many benefits it brings, more and more people are deploying solutions using this tech. So of course, to keep up with that pace, people have to understand how to enforce security within those solutions to prevent any vulnerabilities and weaknesses finding their way into your infrastructure. So this webinar is really aimed at guiding you and highlighting the best way of securely designing your serverless apps. Now, on the panel with me here today, we have a special guest, Alex Casalbroni, a developer advocate for AWS. So hello to you and a very warm welcome, Alex, and thank you for joining us.
Hi, Stuart. Thank you for inviting me. It's, of course, always a pleasure. Nice to meet you all.
Likewise. Now, I've known Alex for a number of years, and there isn't much that Alex doesn't know about serverless architectures. Many of you have probably seen him present at different events across the globe, such as the biggest AWS conference, that being AWS reInvent. So it's an absolute pleasure to have you give us your insight on this topic today, Alex, so thank you very much. Now, just before I hand over to you, Alex, I just want to remind everyone that this webinar is being recorded and you'll be sent a link to the recording as soon as it's available. Also, if you have any questions, then please feel free to use the chat box and we will try to get to as many of them as possible throughout the webinar. So with that in mind, I'd like to hand it over to you, Alex.
Thank you, Stuart. Yes, so I'll try to keep an eye on the question, guys. So ask me anything, and we will have a final section dedicated to Q&A. So whether you want to ask a live question or wait till the end, that's up to you. So yeah, let's get into the content. So what are we going to talk about? What's the agenda for today? I have divided the content into a few sections. So I want to first give everyone a bit of a security background. I'm sure we have many developers, many front-end, back-end developers, data scientists, a lot of different developers and AWS customers are using serverless applications today. So you may or may not be aware of how we think about security and what different services and what's the main way of thinking about security in general, whether you're developing a website or an IoT system or a data processing pipeline and whatnot. Then I'll dive into some of the IAM details related to AWS Lambda. So IAM is the service identity and access management. That's where you configure a lot of the security and permission policies for your cloud applications, and the same holds for Lambda. Of course, Lambda is our function as a service. That's where you put your code, your business logic, your compute layer. And then we'll dive into one of the many pitfalls that often developers don't really know how to handle, which is how to configure applications, what is app configuration, what are the best practices, how do you inject security credentials or parameters or whatever token or password you need to use in your business logic. And then we'll have some sort of Q&A. So feel free to ask me anything in the meantime if you want to dive into specific topics or if you have questions related to the topics we'll cover.
We've had one question coming, Alex. Sorry.
Sure.
Just before we continue, it's probably a good time to address it. If this session includes any hands-on at all?
So I'm not going to show you a lot of things in practice, but I'll give you a couple of pointers and references so that you can build, you can put these things into practice using some workshop material, or maybe Stu, maybe you want to share other material that's available on the Cloud Academy platform. But yeah, I'm not going to show you a lot of code and console hands-on experience today. If you are into that, I can share some resources too. But today, I really want to set the context and to make sure you are aware of the best practices. Hopefully, these integrations are intuitive enough that you can go and test it yourself for your own project easily. Or if you have issues, you can reach out on social media or ask me anything in the chat as well.
Great, thanks, Alex.
Cool, let's get there. So if it's the very first time you hear about serverless, I would imagine it's not for the largest majority of you, but this is sort of the way we think of serverless. And this is Werner Vogels, our CTO of Amazon.com. And when he presents serverless, he says that as developers, and I can relate as a developer myself, what we really want to do is focus on business logic, focus on that code that adds value to our customers, to our the users of our application or whatever you're building. So in theory, everything else, operating infrastructure, spinning up virtual machines, managing clusters, configuring network, even a little bit of the security layer is managed by the cloud provider when you use a serverless architecture. So we'll dive into that. We'll see what is up to the cloud platform, what is up to the developer. And in general, I think what is worth mentioning here is the shared responsibility model. So this applies to any responsibilities in the cloud, but also applies to security as well. So we usually talk about two different layers: the security of the cloud, and that's what AWS is responsible for. That's how we take care of the physical security, and depending on which services you're using, we might take care of different layers of the stack as well. So if you're using a function as a service, so Lambda, there is a lot of network security, operating system, periodic maintenance, all those things that are not your responsibility. We take care of that. And then on top of it, you have the security in the cloud, for which AWS customers, AWS developers are responsible for. These includes things like updating your dependencies if you are using AWS Lambda. If you're using EC2, even updating the operating system and patching all the vulnerabilities of the operating system, for example, is up to you. If you're using Lambda, that's not your problem anymore. So when you consider switching or adopting a serverless mindset, you should also consider how many layers of security and configuration you are offloading to the cloud provider. So you can be faster, you can innovate and focus on what really adds value to your own customers.
I think when architecting on AWS as well, Alex, not just from a serverless perspective, but in kind of any form, having an understanding of this shared responsibility model is kind of key to ensuring you are implementing the correct level of security within your solutions.
Absolutely, totally agree. And I think this is the basics of the cloud. This slide would have made sense 10 years ago when only EC2 was out there and there was no containers, there was no serverless. It still makes sense. What I have seen in the last 5 to 6 years is that the orange layer is getting thicker and the blue layer is getting smaller, so that you have to take care of less things so you can be faster and innovate faster and
Sure.
basically reach the final result, go to production, go to market faster. It doesn't mean that you have less security. It just means that many of those layers are handled by the cloud provider itself. But absolutely. The second thing I wanted to remind everyone is that we strongly believe that security is everyone's job. It's not that as a developer, you ship something, you git push and forget. Somebody will take it and apply it to production, and now it's their problem. So this is part of, if you want, the DevOps mentality, where we also say you build it, you run it, meaning if you design, implement, and build something, you also deploy and monitor and fix the problem. So that's how we tend to structure our internal teams too. And while security is part of that, security is part of operating, is part of maintaining, patching vulnerabilities over time. So that is part of the developer's responsibility as well. Why should you care? Well, there are a lot of different reasons to care about security. I imagine many of you come from the security space and you want to know how to do it for serverless, but I'm sure there are people on the line who are not security experts and are here to learn about what they should care about. So there are many reasons why you should care. You may want to encrypt data to increase the security posture. There might actually be regulations and specific requirements on different projects you're working on that require you to have data residency, data stored in a specific country or in a specific format, or it must be encrypted at rest, or it must be encrypted in transit when you go and access the data. You may need to comply to local data regulations depending on the country you are operating. I'm from Europe, so we know all about GDPR and everything, but now every country is getting more sensitive about this topic of privacy and security, encryption, and the right to be forgotten and all these things. And while we all want to build an architecture and an infrastructure that is compliant to the state of the art, to the best practices. So that's why we're here. I want to share with you how you can do all of this with the serverless applications. I also want to clarify a little bit how the serverless space is different with respect to traditional, EC2 based architectures or containers based architectures. So if you divide the space into the consumer space, things that you have to care about to take care of, and the provider space, which are things that the cloud provider, AWS, manages. We can also basically have different levels of abstractions. You can have the physical server, the virtual machines, the containers, and now the function. So let's try to put there all the different compute services on AWS to give you an idea. So if you're using a bare metal instance, basically you're responsible for everything. You have to put an hypervisor in there, and then you install virtual machines, and then you deploy a container orchestrator, and maybe you put some business logic too. So all those layers are up to you. As you can see, almost everything above bare metal is in the consumer space. You're responsible for basically everything. AWS is, in this case, is only taking care of the physical security of the hardware or of the data center, of the network, and so on. If you move into services like Lightsail or Amazon EC2, well, you're a layer above that. So let's say that the virtual machine layer, you're operating at the virtual machine layer. There is still a lot you have to take care of, like patching these EC2 instances, installing the software, installing frameworks, updating all the code of your application, and so on. We can move one layer above that, so you have some additional isolation, and you might have an orchestrator like ECS or like Kubernetes, whether it's managed or whether you deploy it on your own EC2 fleet. And then we can move one layer up, and here is where we find AWS Lambda. We are at the function layer. As you can see, the consumer space above Lambda is very thin, which is basically only the business logic. This is not really true. There is still things you have to take care about, like configuration and infrastructure as code, and best practices for how to organize your code, how to deal with vulnerabilities in your dependencies, and so on. But let's say that layer is getting thinner and thinner. So most of the concerns, most of the responsibilities, most of the periodic maintenance, for example, is taken care by the cloud provider. So I think that's why a lot of developers are adopting a serverless mindset. So they can focus on what is really relevant to them instead of taking care of the whole stack. And while when it comes to security, of course, we are AWS Web Services, so we build services. And as you can imagine, there are a lot of integrations, security integrations, when it comes to authentication and authorization, or certificates management, or granular permissions with IAM, or how to manage secrets with services like AWS Secrets Manager or the parameter store. So today we're not diving into all of these services. I'll try to focus on the major best practices, but if we have quite, you can use all these services who are managed kind of high-level services that not force you to manage infrastructure or deploy software into a cluster of a fleet of machines and so on. So most of the serverless ecosystem is composed of services that integrate with each other without forcing you to manage servers or infrastructure. So this also applies to most of the security integrations that we are going to see today. And well, if you're
sorry, Alex, I think that slide that was just on showing all the different services shows a lot of different AWS security services. Obviously, not all of them. There's a whole load more, but I think the amount of security services coming out of AWS really helps to demonstrate your point earlier that with regards to the shared responsibility model, that orange layer is getting a lot thicker and the blue layer for customers is getting smaller, because obviously AWS is building more and more security services to help us control that side of it. So as these services expand, it becomes a lot easier for consumers to build on AWS from a security standpoint.
Absolutely, and well, you always have the option. If you are a security expert and you want to still use an EC2 instance and deploy everything on top of it and manage all the operating system patching every 20 days, you're totally free to do that. What's going on is that a lot of integrations and higher level services are being created because customers ask us to take care of this undifferentiated heavy lifting, because they don't want to do it themselves. They maybe don't know how to do it, but even people who know how to do it, they want to offload that and focus on what really matters. Because if you are selling shoes online, you probably don't want to hire the best security experts in the market. You want to use a managed service and focus on your business.
Excellent.
Cool. So I was just mentioning that if we talk briefly about compliance, there are many companies and developers and teams who have to be compliant to standards such as HIPAA or PCI. If you need to deal with payments, there are many more like ISO and PO and SOC. There are many more. The idea I wanted to share with you is that most of the services we'll talk about tonight, so AWS Lambda and API Gateway and DynamoDB and Cognito and Step Functions, SNS, SQS, all these services that are part of the serverless platform on AWS, they are already HIPAA and PCI compliant. So a lot of developers every week or every month come to me and ask me, hey, can I use Lambda to manage credit card payments? Sure, go ahead and do it. It's already PCI compliant. You can go and check. There is a full page with all these regulations basically, and you can check which service is compliant to which regulation. And these things get updated all the time. So a specific service you need maybe is not PCI compliant today, but it might be in 3 or 6 months, and you didn't have to do anything. So one of the best thing I love about the cloud is that it's like you have the best security expert in your team working for you without having to pay for it. So we keep adding more features, more integrations, more security out of the box, more regulation, more compliance, and you just have to basically click a checkbox or just use a specific service that is compliant, and that simplifies also your experience when it comes to providing compliance. Okay, cool. Let's dive into some of the details when it comes to Lambda. So again, Lambda is our function as a service. It's at the very top of the stack right now. I don't know what's coming after Lambda, but for now, it's let's say the top of the stack. So I want to talk briefly about the permission model of Lambda. So by default, if you create a function, that function cannot do much, as you would expect. You can call APIs from the internet if they're public, but if you want to read data from database or push a message into a queue or do all sort of things with cloud services, you have to provide specific permissions to be able to do so. And that's aligned with the idea of the least privileges. You want your functions and your containers and your EC2 instances to have the minimum permissions when it comes to cloud services. And well, by default, they have no permission. If you want to read from a DynamoDB table, for example, you have to create an execution policy that provides a function A permission to read from that DynamoDB table. On the other hand, there are also function policies, and this is another very similar concept that allows basically the opposite. Some services are able to invoke your functions on your behalf. So because everything is event-driven with AWS Lambda, your functions are triggered only when something happens in the system. So there might be an HTTP call, there might be a new object on Amazon S3, or there might be a new object or a new item stored into DynamoDB, and that will trigger a Lambda function. Now, for that trigger to happen, to be successful, you need to provide permission to S3, for example, to invoke your Lambda function. Without that, nobody can invoke your Lambda function. So these are two simple concepts that apply to every function in any serverless system. Now, if you use CloudFormation or if you use the web console, most of these concepts and these requirements are kind of hidden or automated. So when you try to configure an S3 trigger for a Lambda function, the console will ask you, would you want me to add permission for S3 to invoke Lambda? And well, so you click yes, and that function policy is done for you. So when you go and do infrastructure as code and you configure the whole system manually, you have to remember these things. Now,
a quick question
let me tell you. Sure.
Sorry. Obviously, you mentioned about using the principle of least privilege for any of your policies, which is a kind of best practice throughout. That doesn't always happen, not intentionally. So from a housekeeping perspective, with regards to your Lambda functions, how important is it to ensure that you do keep a high level of housekeeping, just to not leave your kind of unused Lambda functions laying around, bearing in mind the kind of permissions that they can have within them?
Very, very important. So I was getting there. Basically, it's important because you don't want stale functions left there with permissions that they don't need. But also, just in case you don't care about that, it's important because it will make you faster. It will make it easier and faster for you to get things to production. Because maybe you're not responsible for security. Maybe you have some peer-to-peer code review, and people will look at your code and your CloudFormation or Terraform templates and suggest that you add least privileges policies to your architecture. And if you don't do it immediately, what happens is that you'll have to do it in a couple of weeks when the comments come back, or tomorrow when you already context switched and started doing something else, and you really cannot remember what is my function doing. Is it only reading or also writing, or is it publishing a message or pushing a message into a queue? So if you do it right now, when you have just written the code, you can just get it done so much faster. And so you don't have a lot of context switching. You don't have to go back and check your code and check what it's doing. You can just do it. And I was getting to the point that a lot of developers take this very, very ugly shortcut that make a lot of puppies cry. Basically, they use star. Okay, so my function can S3 star or DynamoDB star or SNS star. Well, if you use DynamoDB star, your function can not only read and write, your function can delete and create databases and tables and change the configuration and the provision capacity of those tables. So you probably don't want that. You just probably want your function to be able to read or write or both from a specific table. So,
and you see this a lot with other policies as well, where people run into access issues, so they put in the star just to make sure it is working as it should be, and then often
and it feels like a shortcut.
Drill down.
Yeah, it feels like a shortcut. You're getting things done faster, right? The reality is that either somebody will stop you from deploying this code to production because this is not right, you shouldn't do it, or somebody will take your service down and wake you up at 3 a.m. and say, hey, somebody hacked this application, and now they have DynamoDB star access and they started creating or deleting database. So you probably don't want that. So the best idea, the best practice here is apply least privileges as soon as possible. If your function is only reading, you can have DynamoDB get item, for example. And you might use a star somewhere if you want something like DynamoDB get star. So you can get item and get item batch and a lot of other get type of actions. But still, you don't want to have the star in the action field, but also you don't want to have a star in the resource field. You can have DynamoDB get item on a specific table. That's what you want to have in your IAM policies. Because even if you say this function can only read from DynamoDB, you probably, in most cases, don't need a specific function to read every possible DynamoDB table. In most use cases, a function needs to read or write into one table, and that's what you want to configure. And it's not that hard. I want to show you how easy this is. This is a CloudFormation template, actually using AWS SAM. So what you can do here is when you specify the list of policies, you can just add one more policy.
Sorry,
this
Alex,
is a custom
just before
policy.
you carry on,
Yeah.
for those that aren't familiar with SAM, can you just give a high-level overview of that?
Sure. SAM is the serverless application model, and it's a so if you're familiar with CloudFormation, it's how we do infrastructure as code. And so you define this kind of YAML or JSON template that specifies your architecture, all the services, the functions, the queues, the databases that you need. SAM is an extension, or technically it's a CloudFormation transform that takes your YAML, your JSON template, and transforms that into native raw CloudFormation. So if you see here, I'm defining a resource AWS serverless function. So serverless function is not a native CloudFormation resource. The native CloudFormation resource would be AWS Lambda function. So what SAM is doing, it's taking this serverless function and transforming it into a Lambda function and a lot of other resources too. So for example, it will create the IAM role corresponding to these statements that I'm adding in the policies field here. So it's a way to simplify your infrastructure as code for serverless applications. So in this case here, I'm adding a custom policy where I add a statement that provides permissions for this function, which is my function, to call the DynamoDB get item action on a specific DynamoDB table. In this case, I'm referencing a DynamoDB table that is also defined in this CloudFormation template. So you don't have to hard code the name of the table, you can just reference it. So it takes something like 3 to 6 lines of YAML. It's not a lot. And if it sounds like a lot, you can make it even shorter. So for example, in this case, I could do something like this. I can use what we call SAM policy templates to use some policies that are already ready to use for us. So there is this DynamoDB read policy that is parametric. So I can give it a parameter like table name, which is the same table I was using before, but SAM will transform this managed policy, this template policy, into a regular IAM policy. Actually, there is a full list of these policy templates in this policy template list, and as you can see, there are a lot of them. So if you need I like something like S3 read-only or DynamoDB read-only or write-only, you can use these managed policies to get the job done faster. So you don't have to copy and paste 20 lines of a JSON or YAML around for every project. So it doesn't take a lot. I also want to cover another very common topic that many developers ask me. How do I configure my applications? How do I inject credentials? How do I inject tokens and passwords and things like that? So another thing that makes a lot of puppies cry is all those developers, including me, I have done it in my career so many times. You just want to move fast and get some prototype up and running. So you just hard code some secret or some token or the name of a bucket or the name of an API or whatever. You just hard code it in a variable in your code, and that's it. You're done, right? Well, this is not ideal for a few reasons. Well, depending on what it is, it could be a parameter, the name of a table, the name of a bucket, a token, or a password of a database. You know, I don't know how many times you have seen something like this, like a config object in your code with a host of the database, the username, the password, the name of the database. So this is not ideal. You don't want to do that for a few reasons. The most common one is, well, in most organizations, you don't want, often you don't want developers who write the code to have the password or the admin or the username of database in a production environment, but even in a testing environment, actually. So you want to decouple the code from the credentials somehow. Also, if you do that, you will make your functions or your code in general stage independent or immutable. So if I can take my code, compile it, or build some sort of artifact that does not depend on the stage, but that I can tune and basically inject some kind of parameter to use it in a production environment, in a staging environment, in a testing environment. I don't have to recompile and rebuild and re-upload a different artifact every time. I can use my new version of my code, deploy to dev or deploying to stage, and inject the username and the password with an environment variable or with other tools that we're going to see in a second. So this will also help you switch between environments much faster. And it's very common that development teams have at least 2 or 3 environments. So you don't want to recompile and rebuild every time you switch environment. Let me tell you a few different ways you can achieve this, depending on what kind of configuration you're trying to store and not hard code. So the first tool at our disposal is what we call Lambda environment variables. This is very intuitive if you're familiar with environment variables in any programming language or in a console CLI environment. These are key value pairs. They can be optionally encrypted via KMS, our key management service. They are available to your code using the standard runtime API or whatever language you're using. So if you're using Python, it will be os.environ. If you're using Node.js, it will be process.env. If you're using other runtimes, other languages, you would just access it as a regular environment variable. Now, this is super useful for those things that depend on the stage, that depends on which environment you are deploying this function or this code to. So if you have things that change, whether it's a developer, a dev or test or product count, environment variables are a very good tool. So imagine you have a different bucket name in dev and a different bucket name in prod. You can use an environment variable for that. So you can say deploy this code to dev, inject an environment variable with the bucket name for the dev environment. And you can do the same for prod. So that's a very simple way to inject configuration dynamically, but it's not really a great fit for passwords or tokens or secrets. Okay, these things are still kind of things that developers can have visibility into. It's not a password. It's not something critically important that you want to rotate periodically. It's more like something that depends on the environment and that is fairly stable and fixed once you pick it. Then it comes, very often you come to a point where you might have even the same environment variable, but shared across many functions. This is common. You have, again, the name of a bucket that you need to share across 20 functions or 50 functions. This is kind of common. Could be a database name, a DynamoDB table name, or an SNS topic. Now, if you want to change that, and there are 20 functions configured within an environment variable, what you need to do is you need to redeploy 20 functions or 50 functions. That's probably not ideal. So what you want is a mechanism to share this kind of parameters that are shared across multiple functions. So there is a way to do that, and this is actually one of the very few free services of the AWS platform. So it's called System Manager Parameter Store. So in this service, you can store parameters. It supports hierarchies, so you can have something like /myapplication/database/dev, something like that. And in that path, you can store multiple parameters like username and password and whatnot. So it's kind of intuitive to use, and you can fetch multiple parameters at the same time with one API call by using this kind of hierarchy. You can encrypt, of course, these parameters. You can be notified when things change. You have different IAM permissions for who can write and change these parameters and who can read and consume these parameters. Probably for your functions, you want them to read and fetch and consume these parameters but not update them. It's very common. There is also a new way to use it that is not free, but what happened is that many customers needed to have up to 10,000 parameters in their applications. That would be larger, even up to 8 kilobytes. I imagine it could be a very long password, or it could be something like a key or something more complex than just the name of a bucket. So if that's what you need, you can use these advanced parameters that are not free anymore, but give you that kind of additional freedom and scale. In my opinion, this is a very good option, not only because it's free, but because it allows you to centralize these configurations and these variables. I've met many developers that use things like DynamoDB for this. So it's still a key value store if you think about it. And with on-demand capacity, you might have a DynamoDB table where you store configuration, and your functions or your code will go and fetch key value pairs from that configuration table. That's also an option. And I think System Manager gives you a better visibility into who can read, who can write, what are the historical values of these parameters. You can store things in a hierarchical fashion, so that also helps. You might have feature flags in here. You might have secrets like tokens and passwords if that's what you want. But if what you need is something more complex than this, for example, if it's a database password, you probably want to change this password periodically. And probably also you don't want to do it manually yourself. You want to have an automated system or an automated routine or mechanism to do that for you. So there is an alternative to that. You can use another service that is called AWS Secrets Manager. Now, this service allows you to manage your secrets and, most importantly, to rotate them automatically in a periodic fashion. So it's fascinating to me also because the rotation itself is implemented as a Lambda function. So if you want to customize the way the rotation is implemented, you can also customize that. The best part, in my opinion, is that it supports Amazon RDS by default. So, for example, you can have you can create a new secret in the Secrets Manager and configure it to apply to a specific RDS cluster in your account. And the Secrets Manager will automatically, periodically update the password of that database for you. You could say once a week or once a month or once every N day, whatever N makes sense for you. And the Secrets Manager will take care of that password rotation. As long as all the consumers of that database, all the clients of that database will fetch the password and the host name and the username from the Secrets Manager service, you are good to go, because they will be notified and you can fetch the new password. There are other workarounds. For example, if you don't have a notification system and your client finds, for example, an invalid password error in your query, it's very likely that a rotation has occurred. So you can kind of intercept that, go and fetch the new password from the secrets manager and try the query again. So there are ways to automate this too, but the secrets manager is not a free service, and it gives you even a higher throughput. So I've seen cases where customers were using the parameter store, but they needed a much higher throughput. I think by default you have something like 1,000 or 3,000 concurrent invocation limit on the parameter store. So if you need more than that, you can use the secrets manager even for simple parameters, because you have a much higher throughput. And if I remember correctly, there is a fixed fee every month based on the number of secrets you have. So you want to check it out. A lot of customers also ask us.
Just a quick question. How much are serverless applications affected by attack vectors highlighted in the OWASP top 10, for example? And are there ways of mitigating these using the different security services offered by AWS, such as the secrets manager and maybe Cognito, etc.?
Right. So many of those top 10 items are actually apply to serverless applications too. There are a few that do not really apply because they are about network security or infrastructure security, and that's, as we said, is up to the cloud provider, and we take care of that. But many of the other items on that list, for example, SQL injection or dependency related vulnerabilities, they're still up to you. If think of it, if you have a vulnerability in one of your Node.js dependency and it's deployed to a Lambda function, and some attacker is able to exploit that vulnerability and get control over your function, well, they will be able to use your function to do other things, right? So that's another good reason to, first of all, take care of your dependencies, and at the same time try to reduce the surface area and the potential attacks that this attacker can do by using a least privilege approach. So if you say your function can only read from a database, well, if they take control of your function, they will be able to read and read only. They won't be able to mess up with your data or add new records or delete the table. So that also applies to serverless applications. Cool. I'll actually share a resource that will help you map all the different features and services of the serverless platform to those top 10 just in a second.
Okay, cool. Thank you.
So I was saying, no problem. So I was saying that a lot of customers also ask us to unify, to build some sort of consistent interface between the secrets manager and the parameter store. So since a few months, you can actually read a secret from the secrets manager by using the parameter store API. All you need to do is use this prefix here. So /AWS/reference/secrets manager. If you use that prefix, you can use the parameter store API. This is just a way to simplify access to both services, so that you don't have to use two different SDK clients, for example. Well, how do you do that? Let me show you some code. This is Python, but I think it's pretty intuitive, and the very, very similar concepts and patterns apply to other languages like Go and Java and Node.js and so on. So what you typically do is you import the SDK, and in Python it's called boto3. So you want to initialize a client, in this case the system manager client SSM. Then I wrote a very simple get parameter function that is using the client. So ssm.getParameter, you give it a name and you optionally request decryption. This is an interesting take when it comes to security, because if the function has permission to read the parameter but doesn't have permission to access the decryption key, the call will fail. So if you have encrypted your parameter in the parameter store, you need to provide your function with both get parameter access and KMS access to the decryption key as well. So this is important. So you have full control over who can read that parameter if the parameter has been encrypted. And that's it. You can just read the parameter, getting the parameter value from the API response. Very similar if what you need to read is a secret. So in this case, I'm using the consistent uniform system manager API to retrieve a secret using this prefix. So very similar get parameter invocation using the prefix in the name, decryption, same story, and you get your secret. So if this is your Lambda handler, you can just inject a parameter that is centralized in the parameter store or in the secrets manager with a few lines of code. This is probably more like 5 or 6 lines of code. If you really want it to be one, I've built a library just for that. I called it SSM cache, and this is for Python only, but I'm aware there are other related projects for other languages. So this is the kind of interface I wanted to have. I just want to define a parameter, give it a name, and then just get param.value in my code. Same for a secret. You define a secrets manager parameter, and then you just say secret.value. This is also interesting because it comes with additional feature. The initial scenario I had in mind was for caching. So what you want to do is, as you can see here, you want to fetch the parameter out of the handler, right? You don't want to fetch the parameter for every single invocation because this API call has some latency. It could be 10 milliseconds, 20 milliseconds, 30 milliseconds, kind of depends, but it's not, free. And when you are inside a Lambda function, time means cost because you are paying based on execution time, right? So in this case, I am caching the value, I'm fetching the value out of the handler, and then I'm reusing it as long as needed. Now, if this is a password or something that rotates, you probably want to have some sort of caching that expires. So you can use additional features of this library. For example, you can do grouping. I can have a group of parameters with a 5 minutes cache shared across the group, and then I add parameters to it. Or you can have prefix-based parameters and secrets together, and eventually you can even refresh the cache manually. So all the parameters in that group will be fetched again. So it kind of gives you a simpler interface on top of secrets manager and the parameter store, gives you caching functionalities, and also gives you a very handy way to handle failures. So if you know that a secret is going to rotate under the hood without this Lambda function knowing, basically you can use a decorator of your own Lambda handler to intercept a specific exception, something like invalid password. If your database driver has something like an invalid password exception, and the library will help you retry the query after refreshing the cache. So it kind of gives you a simplified interface to also handle refresh. Now, last thing I wanted to show you, to tell you about a new service actually that was introduced at the last reInvent. It's in public beta for a few months now. But what it is, it's called RDS proxy, and this really relates to what we have been talking about so far. So the RDS proxy, if you're using a relational database on RDS, so you have database like MySQL and PostgreSQL and Oracle and MariaDB and a few other databases, Aurora, for example. So what the RDS proxy will do for you, basically you put it in the middle between your application, between your Lambda functions or even other compute platforms and your database. And instead of talking to the database, your application will talk to the proxy. Now, the proxy will do mainly 3 things. First of all, it will help you with scaling the typical connection pooling, solving the typical connection pooling problem that many serverless applications have. So what happens is that usually relational databases have a limited number of connections that they can keep open, right? It's a physical, CPU and memory bound resource, so you cannot have an infinite number of connections. What happens with serverless application though is that your compute layer can scale horizontally up to tens of thousands of concurrent Lambda runtimes. So if every runtime is consuming and using an RDS connection, you will never have enough open connections. So at some point you have some throttling, you have to reset connection, and blah, blah, blah. So the connection pooling problem has been well known for a while. And the RDS proxy will solve that for you, because all the connection with the database will be handled by the RDS proxy itself. And your functions will just talk to this proxy. Second thing is, if there is a failure somewhere, if the master node, for example, fails, you're going to read, what you want to do is you want to switch to a read replica, right? And this is usually code that you have to implement in your database client. It could be your business logic layer. So the RDS proxy will take care of that failover as well, and automatically fail over to a read replica without resetting the connection. So that's another piece of code that you don't have to re-implement yourself. The third thing is that if you have configured RDS with a secret, with secrets manager, RDS proxy will take care of fetching that secret from the secrets manager. So the password, the username, the host name, and also will take care of the rotation for you, so that your function is not even aware of the secret, is not even aware of the password itself. So that's another few or many lines of code that you don't have to take care of in your business logic layer, in your application layer. So it will solve a lot of problems, especially for serverless applications that have to talk to relational databases on RDS. It's going to be GA at some point. It's in public beta, meaning that you can play with it. Of course, I don't recommend running it in production. It's still in beta. And that's it. I want to share an additional resource, as I anticipated. This is a workshop. If you check out this URL, maybe I'll be able to share it in the chat too later. Basically, this will point you to a repository on GitHub that contains a very, very handy workshop that you can run in your own AWS account at your own pace. It's very well documented, and it will guide you through a lot of the things we talk about today, like configuration management and encryption and security integrations with Cognito, with IAM, with web application firewall, encryption at rest, encryption in transit, how do you do distributed tracing and logging and monitoring for a serverless application. So this is kind of the next step. If you have learned something new today, this will take you to the next step, so you can put these things into practice. And now it's time for questions. If you have any question, guys, don't be shy. I think we still have a few minutes available, or if we have any question that was asked so far.
Excellent. Thank you very much for that, Alex. Let me just take a look to see what questions are coming that I can fire across. So I have a question here. Lambda functions are typically invoked either by API gateway or SQS, SNS, and they're struggling to understand how a vulnerability in the third-party node library, for example, could be exploited, since this will typically be behind a number of layers. So it seems to be for the Lambda to be vulnerable, and the event triggers must also be vulnerable. How much is the security of these triggers a responsibility of AWS versus a customer responsibility?
Right. So everything kind of depends on how your function, how your business logic is treating the input event. So what typically happens is that you are given an event object. Inside that event object, you will have some payload, a body to parse, could be JSON, could be other formats. If it's an SNS notification, it's a bit more unlikely. But if we focus on API gateway for a second, you might have a post or a put or a delete method, HTTP call. And typically what your function and your business logic will do is will go and parse the payload of that API. Now, in the regular case where your dependencies are up to date and there is no vulnerability, it's very unlikely that they will be able to exploit some, JSON parsing vulnerability or code injection vulnerability. So unless you're doing very, very nasty stuff like eval or eval, like evaluating a string that is given to you, or very nasty things like that. And most libraries nowadays don't do that anymore. But you might be surprised how many sub-libraries that you're not even using. But maybe the dependencies of your dependencies of your dependencies will do some very nasty, weird eval on some input that you are providing. And if that's user-generated input that comes from your customer or your user, people are very creative. So the suggestion is always try to keep your dependencies, not only the first level, but also the second, third level dependencies up to date. I think this is a good suggestion, not only for serverless applications, but for any application.
Sure.
Every time you take user input, validate it and use a library that is up to date to parse it and to pass it to the next service. Could be a database, could be an orchestration layer that would take that manipulated output and do something else with it. So in theory, I agree with the question that, well, if it's managed by API gateway, you have a lot of options to validate input, for example. So if you know that an integer should come in a specific field, you can add custom API gateway input validation there so that your Lambda function is not even invoked at all. And you can add additional layers of validation and security. But yeah, I agree with you. If there are other sources, other triggers, such as SNS or SQS or S3, it's a bit more unlikely that the payload will contain something that will be able to exploit your dependency vulnerabilities.
Excellent, thanks, Alex. We've got a couple more questions here. When using Lambda functions, we may end up creating many functions to cover business scenarios. How can they maintain the inventory of function services effectively? And is there any tools or services available on AWS to help with that?
Well, there are a few ways. That kind of depends on how you organize your, the function level. You may end up with, as you said, it could be 50 functions or 100 functions or 300 functions. Now, what I would do is to aggregate them into applications, right? So it's very unlikely that one application corresponds to one function. What you typically have is some sort of aggregation at the application layer. It could be a microservice that is handling a few different endpoints, if it's an API, or a few different data processing steps, if it's a data processing pipeline. So there is this native concept of serverless application that was, for example, what AWS SAM was built for. So even in the UI of, even in the web user interface of AWS Lambda, if we have grouped your functions into applications, you can have an application level view of your function. So grouped by application with shared metrics and things like that. So I would say that is the first way to have a sort of inventory of grouped functions. So you can see not the raw level of individual functions, but a higher level picture. In general, I would say if you're using infrastructure as code and defining your function in a JSON or YAML or Terraform template, you should also reference those CloudFormation templates to potentially auto-discover the resources that you have deployed. So it shouldn't be that hard to build your own inventory of how many applications, how many functions, how many stacks we have deployed in a different account. And I have seen other people, other teams, actually use a slightly more drastic approach. So they will just deploy different applications to different accounts. That's another isolation mechanism. So using least privilege approach is great, but imagine that your function has read-only permissions on DynamoDB, but on all the tables in that account. If you want an additional isolation layer, you can just use different AWS accounts for different applications if they are completely independent. And so that function with read-only permission on every DynamoDB table will only be able to read the tables of that specific application. So some teams just go very brutally and and use independent accounts for independent applications.
Excellent, thank you. Got one regarding least privilege here. So when trying to work out least privileges, do you have any tips how to manage that, or is it always down to trial and error, i.e. keep adding permissions based on permission errors until it works?
Well, in my experience, I have to admit it, as a developer, as a software engineer myself, I also experienced a little bit of a friction when I first approached IAM. So my suggestion for all the developers attending the webinar is don't be scared of that friction. You will learn a lot. And I would say it would take you a couple of days to be familiar with the largest majority of the API you are already using. If you're publishing on SNS or reading or writing from a DynamoDB table or doing something else, you know, there are two main resources. There is the CloudFormation documentation, so you have a visibility over the structure of these resources, and also the API documentation, where you see the actual name of the API calls. And also, it's interesting to remember that, you know, maybe you're using Node.js or maybe you're using Python or Java, and there are different naming conventions across all these different languages. So also be mindful of that. All the API, all the actions inside, you know, the AWS platform, they follow a specific convention. So for example, if you're using Python, you have a lot of underscores and all lowercase in your code. If you're using Java, it's all camel case. If you're using Node, it's even different. So keep that in mind. If you want to have the source of truth, just check the API documentation of the service, and there you will find the list of all the APIs. And if you're using the SDK, there is usually a pretty straightforward mapping between the SDK method that you're using and the API name. So if you do that for half an hour and just check the naming convention, it's pretty easy to build a pattern in your mind and be able to guess what's the API name. But yeah, ultimately, just in case, when in doubt, you want to go and check the API documentation. And by the way, that's a great way to learn. Because often these APIs are hidden inside an SDK call that might call different APIs. So you might not even know which APIs you're calling. So I always take it as a learning opportunity as well.
Excellent. Thank you very much, Alex. I'm gonna wrap this up here. So finally, thank you all again for joining us today, and a special thanks to Alex for presenting a whole host of information on how to design and build serverless applications on AWS securely. I hope many of you found it insightful and interesting. I know I certainly did, so thank you very much, Alex.
Thank you, Stu, my pleasure.
You can also find more information on many of the services mentioned today, such as at the beginning, we started talking about the shared responsibility model, obviously AWS Lambda, KMS, IAM, CloudTrail, Organization Shield, and many more within our library here at cloudacademy.com through our courses and hands-on labs. Finally, everyone will receive a recording via email as soon as it's available. And don't forget to check out all our other webinars, which you can find on our website at cloudacademy.com. So thank you very much. Thank you very much again, Alex. I hope we get to do more of these webinars together. It's been great talking to you, and it's been a really interesting topic.
Thank you, everyone. See you next time.
Cheers. Thank you.